Good morning, 8th grade. Welcome to day 3 of week 11. Today is June 3rd. So I just wanted to let you know what you are going to be responsible for today and just kind of take you through the lesson so that I can help you the best I can. I'm at a slightly different angle today just because my cat is where I usually make my videos. So if anything just seems a little different, that's probably why. But I'll do my best to make sure you can still see everything, okay? All right, so we're going to click on our classwork tab as always. We'll go down to day 3. You'll see you have your lesson here. We are focusing on finding the heights of cones given a volume. So yesterday you guys practiced finding just the volume of cones. Now we're going to be given the volume and X to find the height. So very similar to the same kind of flow as we did for the rectangular prism as well as the cylinder, right? We focus on finding the volumes first, then we focus on being given the volume, finding the different parameters or dimensions, however you want to call them. So within the lesson, there's also these 2 support links that take you through the same thing that I'm going to be modeling for you. One is 2 minutes long, one is 1 minute, so just another support if needed. I believe that one of them might use 3.14. Please do not use that in our calculations. You must use a scientific calculator. I gave you the options of the link, or if you have an iPhone, you can turn it. If you have any other kind of phone, I'm sorry I did not post about that. I just don't know the functions of a different kind just because I have an iPhone. But if you would care to share that for anyone else that maybe has a Samsung or any other kind, please let me know. Okay, so the lesson's here. I'm going to use my bigger version just because I think it's easier for you guys to see. So the warm-up asks you to find the volume of the cone. This is what you practiced yesterday, round to the nearest tenths. Most of you did very well on this, so I was happy to see your success with that. Here is the work done for you. I'm sorry, I'm hesitating because I just want to review, guys, that this formula is not the only formula you can use for a cone. You can also use 1/3 times pi times r squared times the height. So on question 7, the error analysis from yesterday, the formula was not the incorrect or the error. That was just a different form of the same formula that we can use. We're using this one just because some of you don't have the scientific calculator at home, so it makes it a little bit easier to calculate using this version. But the formula 1/3 times pi times r squared times the height is correct. So I just wanted to review that, okay? For the warm-up, the diameter was given, so you needed to remember to split that by 2. And then you plug into your formula and you solve by doing your exponents first, multiplying, simplifying the fraction if possible. There's our answer in terms of pi, 9 pi, and then we round to the place value given. So we got 28.3 meters cubed. All right, so we're going to be focusing on finding the height of a cone. We'll start with our volume being out of pi, and then we'll explore when volume is provided in terms of pi. Okay, so I drew the same picture on my board here. So the same thing as always, we're going to start by identifying the information that's given. So I know that we're using a cone, so I'm going to use my formula pi times r squared times the height over 3. That's going to be our formula. I just have to move some of these. Okay. Then we are given the radius. So the radius is 9 feet. Oops. Okay. We are given our volume, 956 feet cubed, and we are looking for the height. Okay, so let's start calculating. So I'll rewrite my formula up here so we have room. So V equals pi times r squared times the height over 3. Okay, I'm going to plug in the information we just listed. So my volume is going to be 956 equals pi times, my radius was 9, so 9 squared times the height over 3. Okay, so first thing we'll do, order of operations, our exponents first. 9 times 9 gives us 81. So we have 956 equals pi times 81 times the height over 3. Okay, the next thing I'm going to do is multiply 81 times pi. I'm going to do that calculation. It's going to be an irrational number, so we'll get a large decimal, but that's okay. We can work with that, okay? Oh no, I'm lying. I'm so sorry. We're going to do something else first. We're going to multiply both sides by 3. Why are we going to do that? Because it's annoying having that fraction there with the 3 in the denominator. So if we multiply by 3 on both sides, I'll put that here. This 3 over 3 will cancel out and we'll only be left with our numerator. So we're going to do that to get rid of the fraction, eliminate it out of our work. If we multiply by 3 on this side, we have to multiply by 3 on this side. And this is where I see a lot of students make mistakes. They remember to multiply by 3 to get rid of the fraction, but they forget that the volume on the left side also needs to be multiplied by 3. So just remember to do that to both sides. Okay, the product of 956 times 3 is going to give us 2,868 equals pi times 81 times the height. Okay, so now this looks much better. This looks like kind of what we were doing with the cylinder at this point. Now we're going to multiply pi times 81. And again, like I said before, it's going to be an irrational number, so we'll get a large decimal, but that's okay. We can work with that. So we have 2,868 equals pi times 81 is about 254.46900 times the height. Notice I'm still keeping those 5-digit rule right after the decimal. It keeps your answer as close as possible to the actual. And now the last thing we need to do is just divide to inverse the multiplication of h to isolate that variable. So I'm going to divide by this very long number. On the right side, when I divide, it will cancel it out and I will be left with h. And on the left side, it will give me a very large digit as well because we're dividing by such a large, oh my gosh, I'm having issues tonight. Okay. Such a large number on the denominator. But then we'll just round. So this quotient comes out to approximately 11.27052 ... Okay? And then the last thing we do, of course, is round to the given place value. So our place value will be the tenths. So we're going to make it 11 point, the 7 would make the 2 go up, 3 feet. Singular units because we're looking for a dimension. Okay, so let's go through that one more time because I feel like I hesitated at one point. I want to make sure it flows. So we have our formula. We plugged in the information that we were provided. We did our exponents first. 9 to the second power, 9 times 9, we got 81. We multiplied both sides by 3 to eliminate the fraction on the right side. If we multiply both this side by 3, we have to multiply the left side by 3 as well to keep the equation balanced. So 3 over 3 equals 1. It cancels out because 1 times our numerator would equal our numerator. So we're left with our numerator and then the product on the left side. Then we did 81 times pi. We got an irrational number. We kept 5 digits after the decimal. And then we inverse multiplication by doing division to isolate our h. We got a long digit and we rounded to the tenths place. Okay, and we included our singular unit. Everything I just explained is on the lesson as well, so if you got a little confused, it's there. I also gave you steps because I felt like it was a little bit easier to kind of just flow through the steps. If you keep using these when you are given a volume out of pi, I think this might be easy to just kind of use this as a guideline to make sure you are solving in the correct order. Okay, so there's a couple more for you to look at. I'll do this one with you. All right, let me just erase my board. Okay. All right. So we are given, Actually, let me see if the other one is. Yeah, I'll do the you do with you, okay? So it looks like a funnel of some sort, but it is in the shape of a cone. So I'm just going to draw a cone. We're given that this length is 10. And we are told we are looking for the height. Okay, and I'll put this here because I feel like it looks a little funky. Okay, and we are told that our volume equals 225 centimeters cubed. All right, so I basically just kind of listed our information, but let's see. So we have volume is 225 centimeters cubed. We are given this time, since it goes through from one end of the circle to the other, this is going to be our diameter now. So our diameter is 10. If we are given a diameter and we are looking for volume, we need a radius. So we have to know to divide this by 2 to get a radius of 5. We do not use 10. Diameter is not a part of the volume formula for a cone. So you have to remember to divide those by 2. And we are looking for the height. Okay, so we're all set. We have our information. Let's get started. So we have our formula. V equals pi times r squared times the height over 3. Plug in the information that we are told. So we have 225 equals pi times 5 squared times the height over 3. Always do your exponents first, following order of operations. So 5 squared. So now we have 225 equals pi times 25 times the height over 3. Now, I don't like working with this fraction, so what I'm going to do is multiply. I'm going to inverse. Division is represented by a fraction line, so this is being divided by 3. I'm going to do the inverse and multiply by 3 to eliminate my fraction on the right side, and I will be left with my numerator, okay, on the right side. Whatever we do to one side, if I multiply by 3 on the right, I have to multiply by 3 on the left, okay, and then I'll be left with 675 equals pi times 25 times h. Now I'm going to do the multiplication of pi and 25 to get that product. So I get 675 equals, this is approximately 78.53981 times the height. Okay, so we're at this point. We're going to continue. We're going to try to isolate that h. So the way we're going to do that is divide. So we're going to divide by this very long number. Okay, on my right side, it will cancel, and I'll be left with my h, which was my goal. And on my left side, whatever we do to one side, we do to the other. So let me rewrite this digit. Okay, we're going to get a quotient that is about 8.59436. And then again, we're going to round to the nearest tenths. I kept it the same most of the time, guys, just to keep it easy for you. So the height is going to be 8.9 would bounce the 5 up, so 8.6 centimeters. Single units because we are finding the height. All right, so that is when you are given a volume out of pi. Now, I'm going to explore one example with you when our volume is given in terms of pi. Okay, I feel like this one is when it's a little easier when the volume is in terms of pi because you are able to cancel out the pi, kind of like how we did with the cylinder. It just makes calculations a whole lot easier when you don't have to do any approximations. Okay, so I'm going to rewrite this problem here and go through it with you. Okay, so we are looking again for the height, and we are given this time a radius of 6 inches, and our volume equals 288 pi. Okay, so again, this is going to be our radius because it's only half the circle, so r equals 6. Okay, we know our volume. Let me put the units so I don't forget. and we are looking for the height. All right, so let's get started on this one. So the first thing we want to do is always write our formula. So we have v equals pi times radius squared times the height over 3. Plug in the information. So v equals pi times, my radius was 6. I don't know my height, over 3. So, oh, I know my volume. Whoops. Okay, my volume is 288 pi. All right, there we go. Now, exponents still first. Always, order of operations, exponents first thing, unless there was parentheses, but there's not. So, 288 pi equals pi times 36 times the height over 3. Now, same as before, we're going to eliminate this 3 because we don't like that fraction in our work. So because a fraction means division, this means this is being divided by 3. The inverse would be to multiply by 3. So we multiply by 3. 3 over 3 will cancel. I'll be left with my numerator. Okay, and then I have to multiply the left side by 3 too. Now, what I want you to do when you are solving with a volume in terms of pi, just leave it out for now and just multiply those two numbers. Leave pi in your product, okay? So you're just going to do 3 times 288 and find that product and then attach pi to your answer. So 3 times 288 is, let me go back to black, I feel like it comes up better. What is it? 864 pi. So 864 is the answer to 3 times 288, okay? 864, and I just leave pi there, equals my numerator. I'm going to use the commutative property and just switch 36 and pi because I just like how that looks better. Usually the number always comes first. So 36, I was doing that yesterday too, if you remember. Okay, now, so simple. The one last thing we have to do is inverse to get h isolated. What operation's happening to the h? Multiplication. So the inverse would be to divide by the terms that are multiplying it. Now watch what happens. 36 over 36 cancels. Pi over pi cancels. I'm left with h. And then we do the same thing to the other side. Okay, and pi over there is going to also cancel. So our pi's cancel out. That's the whole reason why I had to keep it there. Okay, and you find the quotient of 864 divided by 36, which is going to give you 24. So our final answer is going to be h equals 24 inches. Okay, so there's our work. I'll take you through it one more time. Formula, plugged in the volume, plugged in the radius. Exponents first, we got 36, 6 to the second power is 36. Multiply by the denominator of 3 to eliminate the fraction on the right side. Whatever you do one side, you do the other. When you come over here, you're just going to multiply the numbers and leave pi with your product. So 3 times 288, 864 times pi. We get left with our numerator. To isolate h, we do the inverse of multiplication, which would be division. We divide by 36 and pi. Both will cancel on the right side. When we divide by 36 and pi on the left, pi's will cancel. We find our quotient, and that's going to be our height. Attach the units, and done. All right, so that's pretty much everything you have to worry about today. There are steps there to take you through it again when the volume is given in terms of pi. There's a couple more problems for you to try on your own, and then you have your exit ticket. Today's exit ticket is similar to the other day when you have 7 questions, but the 7th question is a challenge question. On the Google form, you are only putting your answer to the challenge question. You only need to submit your answer on the form. That's down here. It explains it to you there as well. You also need to submit the work for only the challenge question. So you'll click on the challenge question. You'll see the Google Doc come up with the challenge question provided. You need both formulas for the to solve this one. You need the volume of a cylinder formula and the volume of a cone formula. Okay? Please show your work in the workspace provided, whether you submit this digitally or if you do it in your notebook and send a picture, or whatever method is working best for you. Just make sure that that also gets sent in because you are getting a grade for both. All right, guys. I hope that helped. Take care. Stay safe.